We have learned all these data types: non-boolean, integer, float, string, tuple, list, dictionary, set, frozen set. And also we have learned that there are two kinds of data types in Python, that are that are mutable and immutable. Mutable means something that can be changed. Immutable means anything that can be changed, as referred as immutable data type in Python. It means that content of that data type cannot be changed if it is immutable. If it is immutable, the content of that data type can be changed. So we have list, dictionary, and set, three different data types. Those are said to be mutable in Python. Other than these three, all other built-in data types are immutable. Okay, so let's go and define how it works. Remember, before we go further into discussing mutable and immutable, how variable works we have learned. Okay, so unlike other programming languages, variable is like an anchor or a label for the data in the memory. Variable serves as an anchor, or it is a mere reference to the value in the memory. Okay, it's like you have stick the label on one jar and peel it off and stick onto the another jar. So it's like a changing a value of that variable. So here, in fact, see, you have a jar, you remove the content and you powered another content, another item into that jar. So you are replacing it's kind of replacing the content of the jar, right? So that other programming languages, it would be like that. Okay, so once you define the variable in a static type programming languages, content of that variable is the variables are bound to specific type. So kind of variables hold those values. But here in Python, these are like references. Okay, so it's like peeling off the label from one jar and sticking onto another jar. So here this a is a variable which is referring to 45. Okay, and so if I assign b also refers to 45. It's like imagine this thing as this 45 is in a jar that has two labels on that. Okay, do you understand? So both are referring to 45, and you can actually put another value, like if you do b equal to 3.14, you are actually reassigning. Okay, you have only one label. That label cannot be placed on two jars at the same time. Do you understand? It can, if you have two jars, jar A you have, okay, box A or box B, this label can be on either box B or either box A. Okay, so you are assigning b equal to 3.14. It means that you are actually referring to another value in the memory. Okay, so you understood this concept. Do you have any questions? It is crucial for you to understand how mutable and immutable data types work. If you actually reassign this. Okay. Now let's move on. Let's define. We have Python here. Let's put a equal to, and which built-in function do we use to check the address ID of that variable? We get the address. Okay, so you see this a is pointing to this address. Okay, so if I put b equal to 3 and then check b, that is also pointing to same address. Okay, it is like this one. Okay, so now if I put b equal to 99, what happened? Check ID of b. It is pointing to different address, like this one. Got it? Like a b, and you assign another value, so it is repointing to, yeah. So I hope that one is clear. Hmm? So now let's go. What happened? You haven't destroyed. It's like, this, you are abandoning just, let's say, uh, let's say you have this thing, yeah. So whatever is the first one, you have uh, a label on this one. Okay. So peel off that label and put it on, this one, last one. So it is just you are abandoning that. Okay, that is not, that is just left there for good. And so in a Python, there's a garbage collector. Okay, so if you are actually from the Java background, Java also has a garbage collector. So that garbage collector runs in a different thread continuously. What it checks, right? What it checks, it actually these abandoned, just like this jar is abandoned when you peel off that label, and considering this as abandoned when you peel off the label and placed it onto another jar. Likewise, those variables are left, which are actually, let's say, if I have signed from B 99 to 102, what happened to 99? It is just there. Okay, and garbage collector in Python removes those values from the memory when no references are pointed to that value. Okay, so so if it doesn't remove those values, for suppose you are doing a lot of this thing, if you are aware, our phones actually are equipped with a finite amount of memory only, RAM only, that can be 2 GB or 3 GB. Okay, in such a case, that RAM, if all programs actually fill up that RAM with this garbage, the values that are not used, the whole RAM will be filled up and phone will be slow. Sometimes it may crash and restart. So uh, here I have assigned, remember this thing, have a 3, a equal to 3. How many references? This is called reference count. Okay, what is reference count? How many references are there for the 45? Only one. Okay, how many references are there pointing to 45? Now 2. This is called reference count. How many are pointing to 3.14? 0. So Python garbage collects those objects which are having reference count 0. So that removes from the RAM. But this is not the case with static type programming languages such as C and C++. So it used to be hectic job because developers needs to remember that if they are allocated some memory, and they are responsible and they are obligated to clear up that memory. So that is the overhead for the programmer. But here we don't have that overhead because Python takes care of that. Takes care of that overhead by garbage collecting value objects that are having reference count 0. So for suppose, what is the reference count for A here? 3 here, 1. Now reference count became 2 because I assigned B. Now repointing that B to re-referring B to 99. Now reference count became 3, 1 for the 3. Now if I assign something else to A, now reference count for 3 is 0. Okay, and that will be garbage collector. That from memory, that would be garbage collector because no variables are pointing to that object. Okay, that is how garbage collector works. So this is called memory management. Python is having built-in memory management. Okay, and now let's come to our discussion of mutable, immutable, uh, difference between mutable and immutable, and how this concept of variables we discussed affects. So now let's do one thing. A equal to let's define colors. Colors equal to red, blue, green. Now let me assign this color. I can append, right, another color. Okay, so what is your favorite color? Yeah, we have red, so let's put purple or orange. Okay. And so red, blue, green, and orange we have. Let Yeah, so let's assign these colors into another variable. Okay, theme equal to colors. Now theme, if I change in theme dot append, okay, and gray, or uh, now check this one. We have that color, right? Go and check colors. Well, so why do you think this thing happened? I changed theme, but why there is a change on colors as well? Let's add color. Uh, both things and colors are okay. Let me tell you one thing. Okay, here name equal to I'm giving Bruce. Okay, I'm assigning hero equal to name. Both are same. Now let me change hero to another thing. Okay, don't mind about spelling. Clark. Okay, now check what is inside name. It is Bruce only. No, it is Bruce. But what is inside hero, which is Clark. Okay, and thing is that you can't. String is immutable. You can't change that. So same thing here. If I assigned color, I have colors and theme equal to colors, which means that I'm assigning a reference of A to theme. So which means that they are pointing to same object. So there is a change in object is reflected on two variables. Okay, that can be verified. ID of colors, ID of theme. Sorry, ID of theme. Okay, but ID of hero is different from ID of name. Why? Because so it is like even though I assigned the previously see, even though I assigned here hero equal to name at that point in time, uh, that pointed hello. So imagine this one as a name, okay, and hero equal to name. So which means that I'm pointing effectively to same object here. Okay, what I assign when I put Clark, okay, which means that different reference. Do you understand this one? I hope you understood what I'm trying to convey here. So Clark is actually the different value in the memory. I'm repointing from Bruce to Clark. So that is the reason we have a two different. They both actually give different values for the ID because they are pointing to different ones. But so since you can't change the immutable data types, if you replace those the values you put, we can't change immutable data types. You understood that, right? So here I'm assigning a different value to variable. It means that what I'm doing, that value is will be placed, created in the object in the memory somewhere, and the way that variable points to that new value. But when it comes to mutable types, they point to the same object. Okay, when we send, and since we can mutate them, we can change those values, and the change here, take a theme and colors. So change in theme. Okay, if I change pop one value, I have violet. Now check colors, both are, can you see, it is reflected because both are pointing to same object. Okay, so this is same for a. Now tell me, here is a pitfall. Okay, if I put a theme to equal to, I don't want this thing to refer the same object. Here I'm assigning, when I'm assigning, I meant to copy that. Okay, so if I put theme equal to theme, okay, sorry, typo. Now theme 2 equal to, let's put append a color. Okay, there's a velvet color. Okay, now check this, that is color, that is reflected at colors, reflected at, oh sorry, color again, sorry for typos. Theme 2. Okay, it is sometimes frustrating. So imagine you assign this value to in a program, and you assigned a list to another variable. Okay, and you made a change to that variable, and sometimes you may not actually notice those changes are reflected in the actual reflected onto actual variable. Okay, sometimes it can be frustrating because sometimes you meant to actually copy. In such a case, that is where copy comes into the picture. Let's put a theme brand equal to theme dot copy. Okay, so what it does, it actually creates that in a different place. It creates a new object in the memory, copies all values into that, and then this variable is pointed to that new reference. That we can verify. Check this one, id of colors, which is same for id of theme, but id of theme brand is different. Okay, again typo, them brand I wrote. Okay, can you see this? Okay, now let's do this thing again, theme brand theme dot copy. Right, now check this one, id of theme, which is different from theme brand. Can you see? Now theme brand contains the same values that are having theme, that colors is having, and theme is 2 is having. Okay, now go and check, append some color to theme brand. Append and put almond. Yeah, any color. Hmm? Yeah, theme brand, we have that all. But check theme, it is not having colors, is not having. Why? Why? Because it, that is what I explained. When you copy, what happens? It it works like a when you copy, it's like you see this value, think of it as colors. When you copy, when you assign, they both point to the same object, so that change here reflects to all references. But when you copy, you will here the copy function creates the same object in a different place in the RAM memory. Okay, and points that and returns that object, and as we assign it to any variable, so that variable points to that new reference, so that both are different actually here. So changes here are not reflected to the actual reference, because the actual reference is pointing to the original object, and as new variable name points to the different one. And that is what we verified that using a ID. Okay, so have you understood any questions? Yeah, that copy is what it performs the shallow copy. That copy. So without copy, let me we have colors, right? Okay, per day colors. Let's put, if I do colors, both birthday colors and colors refer to the same. So I change in, so birthday colors dot pop are reflected here on colors, because they both point to the same object. But sometimes you don't want this behavior, because sometimes you intentionally want this birthday colors to be a copy, that copy, but a different object, so that you don't want any changes reflected onto colors. Okay, so in such a case, I can actually, what I can do, birthday colors equal to colors dot copy. What it does, for suppose, imagine this one as a colors. If you do birthday colors dot copy, the exact copy will be created in different place in a RAM. Okay, we don't see that behind the scenes. Okay, and this, think of A as a colors and B as birthday colors, so that the B would be pointing to the new reference. Okay, B in the sense birthday colors. You understand? So that one, verify that one. ID of colors, ID of, both are different. Can you see? That is a reason, since both variables referring to different objects but the same values. So change in birthday colors dot append of gray. Okay, or reflected or not reflected on actual data type. So actual object, yeah, actual colors object. Now check this birthday colors. Yes. So that is where copy comes into the picture. That is what you can see, help of this dot copy. What it performs the shallow copy. Yeah. So it is shallow copy, means it is not a complete copy. Okay. So shallow copy, let me show you how. For suppose, let me define student. So for suppose Bruce Okay, let me define students equal to, which is a list of students, and let me define name, list of dictionaries. Okay. So name equal to Bob, age equal to 22. Define another one, name equal to Bruce. Okay, age equal to 42. Okay, now let's say staff. I put a staff equal to students. Okay, now check both are same, right? So staff. So probably initially, this is a use case I'm giving you. So I have a students, I have staff. Initially with these two students are they are both students and staff. So that I assign these students to staff. Okay. Later on, these two are actually only these two are intersections. Okay. They only these two members are students as well as a staff. Okay. I want to assign another person who is only the staff from these two onwards. Okay. In such a case, if I assign other person, do you understand here? Name. Okay. Yeah. But since it is exact copy, that is reflected there as. No, sorry, I don't mean to say, since it is a both staff and it is an exact copy, I mean to infer the students and staff, these two variables pointing to the same object. Okay. So this is not intended action, because of course I actually assigned it. I meant to copy, but so here both are referring to same object, so that changes in staff are reflected to student, because it becomes a logical error, right? Without knowingly, you are adding a person to the staff, you are actually making him also a student. So imagine if you in a university, if you go to participants tab, and you will imagine how it is going to be if you see your professors, unit coordinators, or yeah, guides as a students in your group, and you are actually, so that is kind of what logical error. So this is where pitfalls happen. So instead of doing that, okay, staff equal to, I can do students dot copy. What happens here? It is a shallow copy. Students shallow copy. It is not a deep copy. There are two types of copies: deep copy and shallow copy. Okay. So what happens? Since I copied staff, which would be the, of course, I copied both actually having same object, but since I made a copy, ID would be referring to different thing. Sorry. Yes. Right. Both are different, right? Yeah. Both are different here. Now it is a shallow copy. Okay. Let me demonstrate what is uh, how this shallow copy, what is meant by shallow copy. And so this copy function only does the shallow copy, not the deep copy. Okay, so let's put the staff dot append. Okay, put name. Okay, Martha, age 32. Can you see in a shaft? But is it available on students now? No, right? Okay. Now let's do one thing. Staff of 0. What 0 refers to? Bob. Okay. Dot name equal to, let's put Alice. Oh, sorry. I'm accessing it as an attribute. It's a dictionary. Okay. I have updated. Now check, is it updated? Right. The index 0, right? Index 0 is a Bob. I took the index 0 is a first dictionary, and from dictionary I access the key, yeah, name. So I updated that name, right, with allies. That is what you see here. Okay. Now check the students. See how, you see this is a surprising thing. It is updated in students also, but we thought this is a copy, right? Why? Why this thing happened? Why when I appended like a Martha here, which is not reflected in students, but when I change the index one, that is reflected onto students. Why? Remember, it is a shallow copy. Okay, shallow copy means, check this one, ID of staff of 0, which refers to ID of students of 0. Both are same. Same thing for 1. Sorry. Yeah, staff of 1. Right? So, and if I have staff, what happened here? When I copy, since it is a shallow copy, when I copied students, so what Python did, Python actually created a new list, but elements inside are pointing to the actual elements. Do you understand? Okay, so the references inside would be same. Okay, so that is the reason this thing happened. But if you perform a deep copy, what happens? Not only outside list will be created, copied. Inside each element would be uh, copied onto different place. That would be a deep copy. Okay, so let's do one last thing. We have staff, we have students. Okay, let's put students, append another one to append of, okay, name, okay, now age, okay, 48. So now check this students, check staff, both are different. Now change students of -1, which means last one, update name, neo2, okay, lex, okay, check this one, staff, which is not changed, students, but which is updated, because so this one is appended, which means that yeah, students and both ID of check this one, staff -1, ID of which is different from minus, but it is not the case for -2, last second element. right? When, because those are elements from when shallow copied using copy method. Okay, so this is what happens shallow copy. If you have multiple elements, what happens? The outer list, which would be copied, but inner elements, if they are mutable, they refer to the same object. Okay, so that is why it is shallow. It is referred as shallow, effectively not copying each element iteratively, only copying the shallow. That is why you understood why it referred as shallow, effectively copying the outer list, but not iteratively copying each element, where each element inside the copy list would be referring to the same objects. But there is a deep copy is not available on that these data types, but we can use copy library, built-in library. Using that we can deep copy. So deep copy in the sense you will copy the outer list is not only copied and created in different place, each element inside the list would be copied such that they change when you deep copy, changes in the new variable are not reflected to the original variable. Okay, so that is the reason we have copy method on mutable data types. So we have copy on list, we have copy on dictionary, and also we have copy on set.